So we have a diagram which shows the curve y equals x squared plus 4x plus 5. So we've got a curve, which is a parabola, and that is y equals x squared plus 4x plus 5. Okay? And we've got the line y equals 2. So it crosses, these are my axes. Okay, that's 0. And we've got the line y equals 2, which is this line here. Okay. So we've been tasked to find the area of the shaded region, which is this region in here. So we need to find the area of that shaded region there. Okay. Now we're dealing with areas. We're dealing with areas here. So are you happy that effectively we're going to be integrating? Because if we're looking for areas underneath any curve, underneath any graph, we should be dealing with integration now. Okay. So we know we're going to be dealing with integration. However, have a look. Have a look. When we were doing this one, finding the area under the curve y equals 3x squared plus 7x plus 5, okay, we were finding the area between the curve and what? The x-axis. Yeah? So what integration tells you? It tells you the area between the curve and the x-axis. Does that make sense? Yeah? So in other words, when we're dealing with this, we need to be a bit more cunning. Because I can see that this is going to be made up of two distinct areas. Okay? Can you see, first of all, that I could find the area which I'm shading in here? So let me draw it out on the left-hand side, actually. So first of all, okay, I need to find the area underneath the line. I need to find the area underneath the line. Okay, so I need to find this area. Okay, so that's up here at 2. So I need to find the area underneath the line, which is going to be that. Okay? I need to find the area underneath the line, right? And if you think about it, if I want that area in there, so at the moment I've got the whole thing, I've got the whole area. If I want that whole area, shouldn't I just take away the area which I don't want? Which in this case is going to be the area underneath the curve. So if I make another sketch.
Which we can find by the thing.
Absolutely right, yeah? So here's my curve. Here's my curve. So if I find now the area underneath the curve, and if I take these two things away from each other, are you going to be happy? I'm going to be left with the blue bit. Can you all see that? Yeah? So find the area underneath the line first, then find the area underneath the curve, take the two bits away from each other, I'm going to be left with the area which I want. Yeah? So I'm literally going to subtract these two. Okay, so let's do that. Let's do that. So first of all, I need to find my limits. I need to find my limits. Now, can you see on this graph here that the limits, or even on your paper, the limits are going to be the x-coordinates of the intersection points? Yeah? So I need to first of all find where these two things intersect. In other words, where does the line y equals 2 and y equals x squared plus 4x plus 5 actually intersect? Okay? So let's first of all go for the intersection points. Now remember, I only need the x-coordinates because I know the y-coordinates. What's the y-coordinate?
2.
It's 2. Yeah, it's got to have the same height. So it's got to intersect y equals 2. Okay? But in this case, I'm only interested in this point here and this point here, the x-coordinates. Okay? So how could I find the intersection points of y equals 2 and y equals x squared plus 4x plus 5? Absolutely, I just solve them simultaneously. So I just set them equal to each other. So y equals 2, y equals x squared plus 4x plus 5. If I want to find the intersection points of any curves or any graphs, I always set them equal to each other. Okay? So I've got y equals x squared plus 4x plus 5, y equals 2, solve them simultaneously, I just set them equal to each other. So I get x squared plus 4x plus 5 equals 2. Make sense? Okay. How could I solve this? It's just quadratic.
X negative 3 and negative 1.
Hang on a minute.
X plus 3 plus,
Perfect.
plus 1.
So first of all, to solve any quadratic, I need to set it equal to 0. Okay, I need to find the roots of the quadratic. So set it equal to 0. So I do that by taking away 2 from both sides. Then I go for the factoring, which is going to be x plus 3 and x plus 1. Of course, you could use quadratic formula if you can't see that, which means that the two roots are going to be negative 1 and negative 3, or negative 3. Okay? So I know now this point over here is negative 1, this point over here is negative 3. So negative 1, negative 3, negative 1, negative 3. Okay? And then from there, I do exactly as I say. I find, first of all, let's call this area 1, and then I find area 2, and I just subtract the 2 from each other. Okay? Yes?
When we put it in the integration, do we put the negative sign with it? Negative 1 and negative 3?
Well, hang on a minute. What are we going to stick in the integration?
After we do the integration of the equation.
Remember, all this was doing was just finding the limits, just finding the bounds of the area.
Yeah.
Okay? What we're going to do now is find the area. Okay? So we need to find the area underneath the line y equals 2 between negative 3 and negative 1. Find the area underneath y equals x squared plus 4x plus 5 between negative 3 and negative 1, and subtract the two areas from each other. Okay? So let's first of all do area 1. Let's first of all do area 1, this big area. Okay? So we're going to integrate between negative 3 and negative 1, okay, of y equals 2 with respect to x. Okay? What's this going to be equal to? So what's the area function going to be equal to?
Isn't it just a square?
It is a square, and you can work it out as a rectangle, but I'm just trying to apply it generally, because in some cases, you won't have just a nice little straight line, you'll have another curve. Okay? So if you wanted to integrate 2, what would you get? 2x. Okay? And you're doing that between negative 3 and negative 1. But you're absolutely right, if you did it to a square, that's fine as well. Okay? So let's stick this in. So we put negative 1 in first. So we get 2 times negative 1 plus c minus 2 times negative 3 plus c. Okay? Let's have a look at this. So you get negative 2 plus 6, which is going to be equal to 4. Does that make sense? Okay? So the area of this thing up here is equal to 4. Okay? The area of that thing is equal to 4. Now let's do the area of area 2. Okay? So we need to find area 2 first of all. Do I have enough room? I think I might do. Okay? So I need to integrate between exactly the same limits. Remember, the 1 on the left always goes on the bottom. So negative 3 lies to the left of negative 1. So therefore negative 3 is on the bottom, negative 1 is on the top. And I get x squared plus 4x plus 5 with respect to x. So if I integrate this, what do I get?
1 over 3x squared, x power of 3.
Yep.
Plus 2x squared.
Yep.
Plus 5x.
Good.
Plus c.
Good. Excellent. And I still got the limits, which is negative 3 and negative 1. Okay? So just for the sake of argument, I'm just going to move my equals over here. So first of all, I'm going to stick negative 1 in. Okay. And I'm going to take away third with negative 3 stuck in. Okay, so what do I get if I stick those two things into my calculator?
Negative 10 over 3 minus. Negative 6.
Negative 6. Good. Negative 6. So, okay, negative 10 over 3 plus 6 is going to be, somebody?
Negative 10 over 3.
8 over 3?
8 over 3.
Yeah, 8 over 3. So therefore the area of area 2, this area down here, is going to be 8 over 3. All right? So therefore, if I want this area in here, now just because I'm running out of a little bit of space, I'm going to write it up here. So I want the area of the region shaded. That is going to be area 1, the whole area, which is 4. Take away the area down the bottom, which is 8 over 3. So you get 12 over 3, take away 8 over 3. Isn't that 4 over 3?
Yeah.
I think it is. Yep. So therefore, the area of the region shaded is 1 1/3 or 4 over 3.